In this problem, a galvanometer has a coil resistance of 100 ohms and requires 1 milliamp for full-scale deflection. To make this galvanometer into an ammeter reading 200 milliamps full scale, we need to connect a resistance of blank. First of all, since we're creating an ammeter, we know that we want the resistance to be as small as possible. So from this equation, we know that adding a resistor in parallel will decrease the overall resistance, which is what we want. Next, we'll draw a picture of the circuit. So here we have Rg, which we'll call the resistance of the galvanometer, which we know to be 100 ohms. We know that's in parallel to Rs, which we'll use to represent the resistance of the shunt. Next, we know that we have 200 milliamps for full-scale deflection, which means we'll have 200 milliamps of current coming into our system. We also know that we have 1 milliamp going through the galvanometer for full-scale deflection, so the rest of it will go through this lower part, which we can use the junction rule to solve for. So we know that it's going to be 200 minus 1 milliamp for 199 milliamps. Next, we know that since these two are in parallel, their voltages are equal. We also know that voltage equals current times resistance. So the current of the galvanometer times its resistance is equal to the current of the shunt times its resistance. Rearranging this for the resistance of the shunt and adding the numbers given to us in the problem statement, we can see that the resistance of the shunt should be 0.5 ohms. And again, it's in parallel, so our answer will be C.